Hi, my name is Mary Grace Carr, and this is my Physics 2 Lab 2 Lines of Charge presentation. So before we get started today, I just want to give a quick overview of what we're going to be talking about. So first I'm going to give an introduction to the lab, as well as the purpose, and talk about the fundamental physics principles we'll be using in the lab. Then we're going to go into the experiment setup and talk about the initial values, calculations, and observations from the experiment, as well as other assumptions and errors to consider. Then we're going to look through the computational model in GlowScript and talk about the results, and ending with a discussion of conclusion. So to introduce this experiment, we're conducting an experiment involving the interactions between two positively charged tapes. One is suspended and the other is dynamic. This is a continuation of Lab 1, and it's going to display a model of distributed charge rather than the point charge assumption that we used in Lab 1. We're still going to model the electric field here, but there will be an even charge distribution throughout the piece of tape, which will allow us to calculate a more accurate charge. And just the purpose with this is we want to compare the point charge model of the U-tape to the line charge model of the U-tape. The line charge model differs as it was made by dividing the tape into small segments that are multiple point charges, which allows us to calculate for a more accurate charge quantity on each piece. And just as a spoiler alert, the pre-variable result of our charge on the tape is 1.53 times 10 to the negative 8 coulombs. So the fundamental principles that we're going to be using in this experiment is the force due to gravity, which is F is equal to negative mass times the acceleration constant g. We're going to be talking about line charges, so how it's treated as a collection of point charges. We're going to be using the force and electric field relationship. We're going to use the elements of superposition, Coulomb's law, and as well as these two equations here for the electric field of a point charge and electric field of a rod. So just to refresh what happened in the lab last time, there was two U-tapes that were repulsed by one another, and the tapes were attracted to negatively charged objects. So since like charges repel and unlike charges attract, we determined that the U-tapes were positively charged and that they were experiencing a loss of electrons. So just to remind you about the experimental setup, over here on the right we have the diagram of how the thing was done. And the goal here is just to determine the force exerted by one U-tape on another, but just as a reminder, we're using a different method to calculate the charge. Right here, you can see our collected data and observations, which were kind of used as our initial conditions, and some other calculations that we did that we'll look more into at the GlowScript model to understand how we got there. But for our systems and surroundings assumptions, we're going to say our system is our top tape B, and our surroundings is our bottom tape A. So just some assumptions and errors of this experiment is we're going to assume that each U-tape has the same amount of charge, with the charge evenly distributed over the entire strip. Air resistance is also going to be negligible, and it does not need to be taken into account. However, unlike Lab 1, we are no longer treating the tape as a singular point charge. Some errors is just like when taking small measurements, there's lots of room for human error when measuring, and the distance between the tapes might not be accurate, which obviously plays into the overall result. And there could be other forces at play from surroundings on why a charge might behave a certain way. So now we're going to look into our computational model for Lab 2. So you can see here our initial conditions in our code, our electric field function, and then our line charge function. So this is just setting up how we're going to calculate all of these fields in GlowScript. And then you can see here how we have our position for our top tape and position for our bottom tape. And then we have some more like calculations to solve all of these charges based on those equations I talked about earlier in the video. And this was the results from Lab 2. You can see that the magnitude of our electric force is 1.63 times 10 to the negative third coulombs, and our magnitude of our gravitational force is 1.96 times 10 to the negative third coulombs. And pay attention to our free body diagram here to see how all of this behaved. So to just wrap up and discuss what we learned in this lab, if we had modeled our tapes as a single point charge like in the previous lab, as you can see here, I calculated here on the right like what that charge would be and how it's different. So it would have been about 4.7 times 10 to the negative 9 coulombs, while our Lab 2 model gives us 1.53 times 10 to the negative 8 coulombs, which as we can see is a pretty significant change. So obviously our point charge or our distributed charge calculation is a lot more accurate. And when you're thinking about why these estimates differ, which values being like more likely closer to the real value, they differ due to the principle of superposition. And this is because the charge of tape is now spread evenly about the surface rather than just generalized to one point charge. So when you think about it in that context, it makes sense that a distributed charge calculation would be likely closer to the real value. Thank you for listening to my lab. This is all.